Jai Hind everyone, myself Ankita, Faculty of Department of IT, Akgec. Today I am going to discuss important topics of Unit 1 of the course Big Data. The code is KOE097. Now, the content of my today's video lectures are Introduction to Big Data, Challenges of Conventional Systems, 5 V's of Big Data, Types of Digital Data, History of Big Data Innovations, Drivers for Big Data, Introduction to Big Data Platform, Big Data Architecture, and Big Data Applications. So I want to state some facts for you. So there are around 95 million photos being uploaded to Instagram per day. There are around 320 billion emails are sent worldwide per day, and our Google processes around 40,000 searches per second. So we can say that we are generating massive amount of data every second. So this massive amount of data that we're talking about, we can call it as big data. So we can say, according to the IDC report, in 2025, we will be generating around 175 zettabyte of data. Now, 1 zettabyte of data is equal to 10 raised to power 12 gigabytes of data. So could you imagine how much amount of data we are generating, right? So even the definition of big data says, big data refers to extremely large and complex data sets that cannot be easily managed or analyzed with the traditional data processing tools. Now, we are calling all the data that we are creating, which are very much large and complex, and such data that we are creating cannot be processed with the traditional data processing tools. So what are these traditional data processing tools? These tools are, we can say, majorly is your relational database management system, in which we are storing the data in the form of relations or table. It is a tabular format where we are storing the data across rows and columns. So taking for example, if I want to store the data of students across a organization or across a college, we can use this RDBMS like SQL, Oracle, and NoSQL. So we can use these type of RDBMS to store the data in a tabular format. Okay, so I want to store the data of students of, let's say, a college or a university. So I can use these system to store the data. But let's suppose I want to store the data of the students of entire country. In such cases, our SQL or NoSQL or Oracle will not work efficiently. The queries we want to fire will take a lot of time to process. So we can say, for handling such large amount of data, we need the new technology. These RDBMS won't work. Now again, another problem is that, suppose I want to store the photographs of the students, or I want to store the digital documents, digital certificates of the students. In such cases also, our RDBMS will fail, won't be properly worked. So we can say the big data refers to all the amount of data that we are creating so far, and we want to analyze that data. So such data cannot be analyzed by our traditional data processing tools, and for such reasons we need some new technologies called as big data. So what are the challenges of our traditional systems? The first is data volume overload. So as we have seen in the previous slides, that we are creating massive amount of data. Now, when the data amount is increasing, it will cause to slow queries and the system bottlenecks. Now, when the queries become slow, and in this fast-paced world, when we are entering some query to our system and we're not getting the responses on time, obviously that won't work. So obviously our traditional systems was not able to handle such a large amount of data. Second is high velocity data stream. So real time, we are getting the data from the sensors, from the temperature sensors, from the weather sensors. So all these sensors, we are getting the live data. Now we want to process that live data. For that processing also, our traditional data processing tools won't work. Next is high infrastructure cost. Now when we are saying that our data is increasing daily, so for that we need some storage. Now when our data is increasing, so we have to keep multiple storages. Now when we talk about traditional data processing tools, they are storing the data on expensive servers. So when we are increasing the size of the data, we have to increase the servers capacity also. We have to increase the number of expensive servers, which will lead to high infrastructure cost. Second is inability to handle the unstructured data. Now, you can say when we have seen that we want to store the photographs of the student, or we want to store the digital certificates of the students, or the digital documents of the students. So our traditional data processing tools, we won't be able to handle such unstructured data. So such photographs, text, all forms types of unstructured data. Batch process oriented processing delays. So data must go through a time consuming ETL before analysis. So before your big data, we were using data warehousing, data mining tools, which were very much time consuming because it was doing in the batches. So it will always lead to delayed insights and slow decision making. That is not what we want in today's world. So these are the challenges of prediction systems which your big data is going to address. Now, what are the characteristics of big data? So 5 characteristics for big data is volume. We are creating huge volumes of data at very high speed. And third is variety. It is able to handle the different types of data like videos, audios, text, then value and veracity. So we will be discussing them in detail. So what is volume? So volume refers to the sheer amount of data generated daily from diverse sources such as social media, sensors, transactions and more. So we are creating huge volume of data. The sources of data can be many. It can be your social media applications, it can be your IoT appliances, or it can be different sensors that we are having. So we can say that we are creating large volume of data, and this volume of data necessitates the use of distributing computing technologies. So I have told you that it was very expensive to store the data on expensive servers. So in big data, we are storing the data across a distributed technology. So here we are storing the data across various different commodity hardware in a distributed manner. So we're not storing the data on the servers, we are storing the data in the inexpensive commodity hardwares. So here we are using the distributed computed technologies. And when we are storing the data across various distributed commodity hardware, we are able to process the data parallelly, and hence our query execution become faster. Next is velocity. So in today's fast-paced digital environment, data is continuously flowing in the real time from various sources. So organization has to respond to this data influx and get the timely insights. Now take for example, we are using online payments in everything, right? So when I want that if any unwanted transaction happen, I should be able to get the flag right there. For that, we need some real-time analysis. So big data helps to get you the real-time analysis of the even data influx to get timely insights. So we are able to get timely insights even on the real-time data. So these are the two important characteristics of your big data, that is volume and velocity. Volume is the size of the data that we are having, and velocity is the speed at which we are receiving the data. Next is variety. Now variety refers to the diverse type of and formats of data. So we are dealing with the data like text, videos, audios, so much amount of data. So the big data is able to handle all formats of data, and these types of data can be categorized into structured, semi-structured and unstructured data. So structured data is organized easily and easy searchable. That is the table, that is data that is stored in the tabular format. That is called structured data. Unstructured data includes text, images and videos. So all these types of data can be easily handled by your big data. Next is veracity. Now whatever data we are storing in the big data, we have to analyze that data, right? That's why we are storing it. Otherwise there is no use of storing the data in big data. So the data that we are storing should be a high quality data. It should be accurate and trustworthy. Why? Because we have to take some decisions. We have to draw some actionable insights from that data. So if that data is poor data, or if that data is of low quality, it is wrong data, and if we are making decisions based on that wrong data, obviously our decision will be wrong. So it is very much important that the data that we are storing in the big data should be high quality, accurate and trustworthy. We have to ensure the integrity of the data. because we are making important business decisions based on that data, right? So the organization must implement rigorous data validation and cleansing processes to ensure that information they rely on is accurate and reliable. So data integrity also encompasses the need to evaluate the sources of data. The sources of data means from the data sources from where we are getting the data. It could be some websites, it could be some data from the IoT sensors, it could be from data from the feedback form, right? So this is important that the data, whatever data we are storing, should be high quality and accurate data. Last one is value. Value means it refers to the actionable insights and benefits that can be derived from analyzing that big data. So whatever insights that we are deriving from the big data should be useful for me in business. So if I am drawing some insights which won't help in my business, then that big data won't add value to me. So why would I spend my money in or investing in big data when I am not getting any profits from that data? So obviously, value is very much important because the true value of big data lies in the ability to inform and guide business strategies, optimize operations, and enhance customer experiences. To unlock the value of big data, organization must invest in advanced analytical tools and skilled scientists capable of deriving insights from the complex data sets. So obviously, it's very much important that our data that we are storing should give me high value. It should give me better insights that can I use in my organization to for my profits. So these are the 5 most important aspects of big data, or we can say these are the 5 most important characteristics of a big data, that is volume, velocity, variety, value, and veracity. So volume is that huge amount of data that we are dealing with. Velocity is the speed in which we are dealing with the data. Variety means we are dealing with structured, unstructured, and multimedia data. Value is whatever data that we are storing should give us some value. Veracity means it should be very much high quality and consistent. So these was the characteristics of the big data. Next is, what are the different types of digital data? So we have 3 types of digital data, that is structured data, unstructured data, and semi-structured data. Now, structured data refers to the data that can be stored in a tabular format, that is your relational database. Whatever data that we were storing in your RDBMS all goes in your structured data, that is Oracle, IBM DB2, Teradata, all these are the examples of your structured data. So what are unstructured data? Unstructured data means the data that is in the form of images, in the form of videos, in the form of text. That forms your unstructured data. That is data from the Facebook, Instagram, all the social media applications we are dealing with. All are generating a large volume of unstructured data. Semi-structured data is in between the structured and unstructured data. It doesn't have a clear structure, but it do have some structure. So it is in between your structured and unstructured data. So as we can see in this pie chart, around 80% of data that is being generated is unstructured data, and only 10% is structured and 10% is semi-structured. So our main target is to draw some technologies which are able to handle such large volumes of unstructured data, and mind you, it's very difficult. It is not as easy as structured data, in which we were storing the data in the tabular format and we were firing the queries on the basis of the columns. So handling structured data, unstructured data is a tricky task. Now example is shown by this slide. Unstructured data, you can see, first let us do the structured data. Now this is the same, I am storing the information of around 5 people in the form of structured data. I have provided them a unique ID and the name, age and degree. So I have presented the data in the form of relational database. Now, if I want to store the data as a unstructured data that you usually get, that is in the form of sentences. The university has around 5,600 students. John ID number is 1, he's 18 years old and already holds a BSc degree. So this is the example of your unstructured data. Similarly, if I want to represent the same data in the form of semi-structured data, I will be using some user-defined tags. Now, this is your XML. In XML, we are using the user-defined tags That is, I have a university, then I have a student tag, then I have a name tag, age and degree. Similarly, I can do. So this is example of your semi-structured data. In semi-structured data, these number of records are not fixed. I can change according to my will. In this ID1, I can store name, age and degree. In maybe ID2, I skip the degree. So this is the structure is not stringent. Whereas in your structured data, we have to write every record. So what are the difference between these three databases? Let's see. Structures type of data says data is mapped in a relational database, whereas in unstructured data is mapped on the basis of binary and simple character. It is just a textual data or a video data or a audio data. So we have to convert them into binary and simple character to be able to analyze it. Now here the data is mapped in the XML format, that is user defined tags. Scalability, data is schema dependent. If the data fits into my schema, I will store the data. If not, I won't be able to store my data. So it means it is less flexible. It is totally flexible because we can store the data as we want. How much data we have, we can store it as it is. Whereas in semi-structured data is more scalable and flexible than structured data, but less flexible than unstructured data. It lies somewhere in between structured and unstructured data. Performance, obviously, when we have a fixed structure, our performance will be high. So in the structured data, we have highest performance, whereas in unstructured data, we are using only textual queries. So you are aware of regular expressions. So we have to use regex queries to query from our unstructured data. Whereas in semi-structured data, we are using anonymous queries. Okay, so we are using some various different types of parsers to parse the data that is stored in the semi-structured form. Obviously, it is a highly organized data, it is unorganized data, and this semi-structure is in between your structured and unstructured data, that is partially organized. Now, next topic is of history of big data innovation, how big data started. Now, basically, big data started in the year like when we were starting the use of social media applications, our Facebook, before Facebook, there was Orkut, Facebook, Instagram, all were creating massive amount of data, YouTube, right? So we need to handle that data. So from there only the notion of big data arises that when we are creating so much amount of data, we should be able to analyze that data. Now, when we want to analyze the data, we have to store that big data in efficient manner so that it can be analyzed. So we can say in year 2000, big data term was coined by John Almache to describe the large scale data challenges. So in year 2000 only, the big data was term coined. In 2001, Gartner Derglani proposed 3 V's of your big data, that is volume, velocity and variety. Veracity and value were added later, but at that time only 3 V's were proposed by Gartner Derglani. Now in 2004, the Google published a MapReduce paper, and MapReduce is a programming model for processing large data sets in parallel across many machines. So in 2004, Google published its MapReduce paper. It published it about the GFS, that is the Google file system, which helps to process the large data set in parallel. So in 2006, Yahoo created Hadoop framework, an open source implementation of Google MapReduce and Google file system. And Hadoop allowed businesses to store the process of petabytes of data across clusters of commodity hardware. So basically, when we start off history of big data, it is very important to name 2 scientists, that is Kafrel and Dog. Now, the Kafrel and Dog were working on an Apache Notch project, and when they were working on the Notch project, they were able to see that they have to handle large amount of data. For that, they took the idea from the MapReduce paper and implemented them and released in an open source implementation of Hadoop. In 2010 to 14, the NoSQL database like MongoDB, Apache Cassandra were being used to store the data, analyze the data of social media, IoT and e-commerce platform. Similarly, in 2014, around 13-14, there was a rise of cloud computing, AWS, Google Cloud, Azure. So all these were shifted to cloud. Now in 2015, the AI or big data intelligent decision making is there. We are using BERT and ChatGPT for, storing the large amount of data, and this data is analyzed by this ChatGPT to give you some new information. And also we are using Apache Kafka and Flink to allow real-time processing of the social media, stock market and IoT data. So basically we started with the 3V model, and then we gone through your GFL, that is Google File System, MapReduce, then Hadoop, then NoSQL, then cloud, and now we are at the intelligent decision making using the ChatGPT models, BERT models, and now the last we are dealing with streaming data analytics. We are still working on it and we will do better in future. What are the drivers for big data? There are mainly 6 main drivers that can be identified. First is the digitalization of society. So all of us are digital. We are using mobile phones, we are using laptops, we are using iPads. So our whole society has been digitized. We are using internet and we are using all of those appliances which are, IoT inbuilt. So our society has been digitized. So we are generating. So when we are digitized, we are generating large amount of data, right? Second is plummeting cost of technology. Now these two are interconnected because of the low cost of the technology. We are using the digital sources in a very huge manner. And when we are using the digital sources, we are creating large amount of data. Now, when we are creating that large amount of data, it is getting stored and the organization are wanting it to, use them for their own benefits. So, analysis of that data is also being important. Next is connectivity through cloud computing. Increased knowledge about data science. Now, this is used to analyze the data that is being generated, right? So, big data is analyzed by your data science. Social media applications, we are getting used to the social media applications. We are writing our posts, we are getting some feedbacks. So these are also contributing to the big data. Upcoming IoT devices, we are using various IoT, you can say ACs, right? So all these are generating the data and contributing to the big data. Now, what is a big data platform? So, we have understood what is big data. What is big data platform? So, big data platform is an integrated hardware and software system which is designed to efficiently collect the data. We have to collect the data from the various data sources. Then we have to store the data efficiently. Then we have to process the data, we have to clean the data, and we have to analyze the data. And then after analysis, we also have to manage the large scale data sets. So, the platform which is able to do all these processes, we call it as big data platform. So, it combines various big data technologies into a unified solution to handle structured, semi-structured and unstructured data. The examples are Apache Hadoop, Spark, Google Cloud, BigQuery, Azure. So, all these are very much important examples of your big data platforms. Now, what is the big data architecture? So, big data architecture is a architecture of a big data platform. So, it should be able to ingest the data, process the data and as well as analyze the data, right? So, it can means we can store the 100 of GBs of data to while other it means hundreds of TBs of data. So, we can store as much of data as we required. Next is the cost of storage has fallen dramatically, by which we means the data collected keep growing. So, since the storage cost of hardware is reducing, so we can store as much data as we want. Next, some data arrives at a rapid pace, whereas, so now there are various space of data we are getting. So, some data can be in a slow pace, some data can arrive at a rapid pace. So, we have to, cater all those speed, that is slow data as well as fast data in our big data architecture. Next is we might be facing an advanced analytic problem or one that requires machine learning. So, these are the two ways of analyzing the data. Either we can use analytics or we can use machine learning to analyze that data. Now, this is the big data architecture. First is your data sources. Now, these data sources can be many. It can be your social media applications or IoT sensors or your business applications. So, these are the various sources of data from which we can capture the data. Now, this data should be stored. Now, there are two ways we can store the data. First is, if it is an enterprise data, we can store in a batch processing manner in the data storage. So, we have to convert the data into a format that can be easily analyzed. Next is your real-time message ingestion. The data that we are receiving from the IoT sensor, the temperature sensor, the weather sensor, so these are the real time of data. Now, this real time data should be also stored in a real time message ingestion manner. In that way, it means that we are storing the data in an intermediate folder, and the data keep on coming to that folder, and we are storing that data into that folder, and from that folder, we are using it to store in a different data store. So, that is your real-time message ingestion. Now, when we are storing the data, these are the two means by which we can store the data. We can store the data as batches or in the real time as well. So, to process the data, we have for the data storage, we are having using batch processing, and for the real-time message ingestion, we are using stream processing. So, basically, this is a process at which we are just cleaning or, making our data prepared so that it can be easily analyzed. So, these are two ways. The data that is stored in a batch processed manner, it is batch processed, it is cleaned, transformed in a way that can be analyzed by the systems. Stream processing also done so as to prepare the data for its processing. Now, the data that we have get from the batch processing as well as stream processing, this data can be used by your machine learning algorithm. Now, this machine algorithm uses the data to train themselves. So, these machine algorithms are using this vast amount of data to train themselves. Next, after the data is being processed, we have the data in a format that can be easily analyzed. We are storing that into an analytical data store. Right now, this analytical data store will store all the data in a proper format where we are removing any inconsistencies. We are just cleaning the data and storing it. And this analyticals and reporting tool is actually generating insights, actionable insights from the data that is stored in this data store, right? Next is your orchestration. Orchestration is basically managing the whole workflow. So, orchestration, the purpose of orchestration is to manage the whole flow of information that is happening across the big data architecture. Next, these are the big data applications that we are using. First is your business and marketing. Here, the business is heavily using the big data application to analyze the customers and also to recommend our system. So, we can see whatever we are browsing on the Google, we are getting corresponding ads for it. So, recommendation and customer analytics is a very much important application of your big data. Next is healthcare and life sciences. Now, if we are storing such amount of big data, we can predict the disease outbreaks or also offer personalized medicines. Then is finance and banking. We can detect fraud, and algorithmic trading means that the system is telling us what shares we need to buy to get the profit. Next is social media and entertainment, user engagement analysis that is used by our social media applications like YouTube and Facebook. They are using our data, using our browsing history to understand our nature and provide the content right? So, user engagement analysis, content recommendations, piracy detections, identifying and preventing unauthorized distribution of content is all the application of social media and entertainment. Now, in retail and e-commerce also, personalized marketing, optimizing stock levels, price optimization is all the application of your big data. So, the prices of the products on these retail markets can be changed according to the demand. So, if the demand is high, they can increase the price. So, they have to first analyze, right? Then there's IoT, traffic management and public safety. So, all these also helps in managing the traffic. So, IoT is using your big data to, gain insights on the traffic management and public safety. So, these are the major big data applications because, we are using machine learning, we are using ChatGPT. The food of all these analysis tools is your big data only. So, big data is very much important. So, in this video lecture, we have discussed about the introduction of big data, about the various drivers of big data, about the various types of digital data, then architecture of big data and big data applications. Thank you.